Hey guys, welcome back. So in order to proceed for the next step, we need to first generate the data that we can use with the render. And let me delete that. So I'm gonna isolate the two large one, and let's delete this. I don't need it, and I don't need this. So we have a large, let's call this large layer 1, layer 2, and mid layer 1, layer 2, and then fine details or small details. And all we have to do is export these as EXR files. So if we go under the raw output node, we don't have to have let's do a new node. So let's create an ocean, evaluate. This does more than deforming the surface really. So here I'm going to provide the spectrum, and I'm going to go under the export to attribute, and I'm going to turn on I'm going to change this to displacement in RGB, cusp in alpha, and we don't need any of these options because this is only related to the geometry. If we wanted to have preview, and I don't need this on because this is only for deforming the geometry. And that's it. We make sure that the map is set to the correct resolution, and then I'm gonna write it to maps live ocean displacement. I'm gonna rename them. So I'm gonna call this large layer 1. I'm gonna write one map and leave all the settings the same. I'm gonna copy this, and this is layer 2, and let's save to disk. It's writing frame 44, so I'm gonna go to the first frame, and let's make sure both of these have the same settings in terms of resolution. Save to disk. Cool. And let's copy this. Now for the mid. And we have to be careful with to not overuse the resolution, because this is going to decide how big the displacement map is, whether it's 2K, 4K, or 1K, and so on and so forth. And the higher this value, the slower the export time, the bigger the displacement map, which will means the slower the render time. So we have to be careful with this. For the mid and large, 10 is fine. 10 is enough or plenty. And then for the high res, I'm going to use 12. Okay, so mid layer 1, I'm going to copy this. Mid layer 2, and copy this. And then small. And let's set this to 12, this to 10, and this to 10. Select, hit save. Obviously, when you have when you need the full sequence, you need to write multiple frames, and this process takes a bit of time with multiple maps, but you just have to do it once. Now, for the iteration, the only way is to use a lower resolution in these maps to get a sense of the scale, the speed, and basically everything about the ocean. Lowering the resolution is not going to change how it looks in terms of motion. It's just going to decrease or lower the amount of details, which is fine. For the preview, you can get a very good indication with all of these. Now we've written the maps out, and now we need to prepare this so we can visualize it. Now this workflow is designed so that it works with Redshift, but because we're doing everything at render time, we don't have any geometry in the viewport to visualize. Oh, we're mixing these and these and this. We want to be able to have something in the viewport where we can see our ocean if we needed it. And the reason for that is because, well, we can do sims with it. We can use it for to understand the scale of the ships or anything we need the geometry, and so this workflow is gonna provide us with the mesh in the viewport in Houdini, as well as an exact copy at render time. And while I remember, let me import the ship. So I have a ship, and let's go up, create a geometry node. Let's dive inside, and this is our ship. And that's our ocean, and it's just for a scale purpose, and we need to be able to get enough details from this angle, from this angle, and from this angle, so all of it, and we're going to be able to do that. Okay, so the next step is, once we have all these maps cached, we're going to create the grid or the geometry that is going to be passed to the render, and then let me call this ocean geo render. And the idea is, we want this grid, we're going to pass this to Redshift and assign these maps as displacement maps. Now, to assign displacement, we obviously need UV coordinate, but we have different maps. We have 3 of them, and each one needs a specific UV coordinate, so we have to create different UV coordinates for each of the maps. Okay, and or we have to find a scale where we can place all these maps on top of each other and just use a multiplier to the UV coordinates so that they tile properly, and we'll do that in the next video. But for now, I'm going to create the grid, and it's going to be a huge grid, 5000 by 5000. And we don't need a lot of resolution because all the details are going to be coming from the render itself, so we don't need a lot of details here. We're going to subdivide it at render time and get the details. And this is the final one. I'm going to make a smaller version so that we can see all the details here as well once we read the maps, because I want to get the preview from the maps as if we're doing it in the render, and then we're going to recreate everything in the shader. So we'll do that in the next video. Thank you guys for watching, and see you in a bit.